In this video, I want to go through this example where we're given a PDF, probability distribution function, for the random variable x, and it involves these terms a and b, and we're given the expected value of x, and what we want to do is we want to find what are a and b, what are these constants. Okay, so this comes from a really good question from our discussion board, and so I want to address those questions and work through this problem. So the trick to this type of problem, first you need to recognize that you have two unknowns, so there must be two equations that you do know, right? So if you have two unknowns, then you need two equations, and then you can solve for the two unknowns. So the first thing that you know is this is a PDF. Okay, because this is a PDF, what do we know about PDFs? All PDFs integrate to 1. So if I integrate from negative infinity to infinity of f of x dx, I should get 1, right? That's a property of a PDF, right? Property of all PDFs, okay? Probability distribution functions. Okay, so let's talk about what this PDF, so this PDF from negative infinity all the way until I get to values that are less than 1, the PDF is 0. It's only when x is between 1 and 2, including 1 and 2, then f is this, a plus b. Otherwise, it's just 0. So I could have written this, so from negative infinity to 1, f of x dx, plus 1 to 2, f of x dx, plus 2 to infinity, f of x dx, right? This is using an addition property of integrals, right? We can break up our integral like this, right? So basically calculating a series of areas and then adding them up. And because this limit meets that limit, this one meets that limit, this is the same thing as the integral from infinity to infinity. Now, the person who posted this question in the discussion board asked, is it meaningful that we have this equal sign here? Well, when you're calculating this integration, no, it doesn't matter if this is x is greater than 1, less than 2. That's exactly the same thing as x greater than or equal to 1, less than or equal to 2 when we're doing this integration. Now, when it becomes important is if later you want to know the value of f when x equals 1. Now, with the equal sign, you go up here. If there was no equal sign, then you would say the value of f at 1 is 0. Okay, so but in terms of your integral, no, it doesn't matter, right? Okay, so this down here from negative infinity until 1 is 0, right? This right here, this is a plus bx dx. This right here, this is also 0. When you integrate 0, you get 0, right? So really, it's just this. A plus bx dx equals 1. All right, so this is my first equation. And let's go ahead and figure out what this integral is, and so then I have a little more simplified of an equation. Okay, so if I integrate over x, I'll get ax plus 1/2 bx squared evaluated from 1 to 2. So this would then be a times 2 plus 1/2 b times 2 squared minus a times 1 plus 1/2 b times 1 squared, which is just 1. Okay, so this is 2a plus b, 2 squared is 4, 4 divided by 2 is just 2. So 2b minus a minus 1/2 b. I can simplify this a little bit further. So 2a minus a that's A, plus 2b minus half b. This would be minus or plus 3 halves b. Okay, so remember this equals 1. Okay, so this is my first equation. So that's one equation down. All right, so I need two equations, two unknowns. Right now I cannot solve, right, for both A and B. So good, they gave us another piece of information, and so now I need to use this fact, the expected value of x is 1/2. All right, so what is expected value of x? In general, expected value of x, you integrate from negative infinity to infinity, x times f of x dx, right? This is a general property, right? So now I want to go ahead and do this for my function. Okay, so I'm going to move over and do this over here. Okay, so I know that the expected value of x should then be from negative infinity until we get to 1, which is just going to be 0. So let's just go ahead and start from 1 to 2. Oops. So from 1 to 2. From 1 to 2, x times a plus bx, that's what f of x is, dx. Okay, so now we're given that the expected value is 1/2, so let's write that over here on the left-hand side. All right, let's go ahead and distribute that x. So this becomes ax plus bx squared dx. All right, and now let's go ahead and do this integration. And so I'll have 1/2 ax squared plus 1/3 bx cubed, evaluate it from 1 to 2. All right, so let's go ahead and plug in those bounds for x. So this would be 2 squared plus 1/3 b 2 to the 3rd power minus, I need to plug in 1 for x. So this would be 1/2 a plus 1/3 b. All right, plugging in 1 for x. Okay, so I have, let's see, 1/2 times 2 squared, that's going to be 2. So I have 2 a's there. Plus, this is going to be 8/3 b minus 1/2 a minus 1/3 b. Distribute that negative sign. Okay, so I have, let's see, 2a minus 1/2, so that is 3/2 a. I have 8/3 b minus 1/3 b, so that's plus 7/3 b. All right, great. So this is my second equation. 2 equations, 2 unknowns. I can solve this. All right, let me go ahead and move my screen. So there are my 2 equations. Okay, so 2 equations, 2 unknowns. I can solve this. Number of ways you can solve this. Probably the easiest is to go ahead and figure out what a is with this equation over here. So I'll go ahead and say, oh, okay, a equals 1 minus 3/2 b. Okay, now plug this a into this equation, right? That's the way you solve when you have 2 unknowns, 2 equations. You can do the substitution method. Okay, so this would then become 1/2 equals 3/2. Now I have a is 1 minus 3/2 b. Okay, and I have b here. So great, now I have an equation that only has b. I can solve this. I can solve this for b. All right, so let's go ahead and do it. So we have, go ahead and distribute this 3/2 here. So this would become 9/4 b plus 7/3 b. Okay, so let's see, I can subtract 3/2 from both sides. All right, and I have negative Let's go ahead and get common denominators on the bottom here. It looks like it would be 12 as the common denominator. So let's do 3 on this one. So this would be 27 over 12. And 4 for this one, so this would be 28 over 12. Okay, so multiply this by 3 over 3 and multiply that one by 4 over 4. So I have common denominators. Okay, so on this side you have 1 minus 3, so that's negative 2 over 2. So that's minus 1 basically. And then we have minus 27 plus 28, so that's just 1 12th b. Okay, so negative 1 equals 1 12th b. So multiply both sides by 12, get negative 12 equals b. All right, now bring that over to figure out what a equals. So now that you have a, or now that you have b, you have this equation for a. So now let's figure out what a equals. So a equals 1 minus 3 halves times negative 12, right? I plugged in for b. So this cancels, that makes this a 6. So a equals 1 plus, negative and negative makes a plus. 3 times 6 is 18. So a equals 19. Okay. All right, so a equals 19, b equals negative 12. 19 and negative 12. So I would go over here, and my answer, the function should be f of x equals 19 minus 12x when x is between 1 and 2, 0 otherwise. All right. So if you were to, first thing, this is a PDF. If you were to integrate over it, you would get 1. Second thing, if you were to find the expected value of this, you should get 1/2. Okay. And so there you go. This is the solution. A is 19 and B is negative 12.